Hit it.
Alrighty. Today we're talking about the substitution reactions of the SN2 and SN1. We're going to start out with the SN2. Duncan and I love to have a lot of fun. Dang it, we're starting with the SN1. I did it again. See, we always started with the SN2 anyways, so... yeah, I know, right? So we're going to synthesize 2R2-bromobutane 2-ill-cyclohexane to form. We're gonna form 2S2-cyclohexane-butane 2-ol. So from here we're going to. The nice thing about SN1 is it's going to form a carbocation, and so we're gonna have multiple products. But the first step, what we're going to do is this bromine is going to go ahead and come off, and so those atoms or those electrons, they're going to come over here and they're going to form this this bromide. That's going to form this carbocation. And then in the presence of water, this water is going to want to flock to this carbocation on either direction. This is going to cause the multiple products that we get in the very end. So this is the second step, where the water goes on as a whole. As you see here, now the positive charge has become is now on the oxygen, and let's see, just like that. Oh, I guess we need to do this, don't we? So this bromine, the bromine that came off earlier, it doesn't really like being all by itself. It's kind of lonely. And so it's going to take its extra lone pairs and it's going to want to steal this hydrogen off of this oxygen. And this oxygen is actually going to want to give it up anyways because it hates being positive. Essentially the same thing's going to happen here. It's going to come over here and steal the oxygen. I kind of forgot to put a positive up here. And then that's gonna eventually neutralize everything, as we see here, where we have a neutral atom here with 0 charge, and then the bromine's also neutral. So they're two different products. I think they're diastereomers, and then but they're still considered two different products because one has attacked from one end while the other has attacked. So like when we added this water coming in from both sides of the carbocation, we end up with these two products here. SN2. Look at that pretty handwriting. Duncan's amazing.
Alright. This one's much simpler. We just start with 2S2-isobutane, and what's going to happen is this nucleophile is going to attack right away. Okay. That's going to push the iodide off, and essentially it's going to do a umbrella movement. So as it goes this way, all the formation goes from going this way to eventually it's going to flip with this force, and it's going to flip going this way, as you can see going right here. So we're pointed this way. This hydrogen is going this way, essentially, and this one. And now we're headed this way. So that cancels that. The iodide comes off, and it forms a thiol, or a thiol. It forms 2s-butan-2-thiol. And that is SN2 and SN1.